Hello everybody, in this video we are going to learn logarithmic function and exponential function. So first we will study exponential function. So let's start. So we have exponential function has function of x is equal to a raised to x, where your a should be greater than 0 and it should be not equal to 1. This a is your base and this x is your power of this base, or you can say that this is the exponent of your base. Yeah, so this is our exponential function. So let's draw graph for this. Let's consider base has 2 and your x values will be changing values. So what is the domain for this function? What is meant by domain? Domain means the possible output inputs that we can give to this function. So possible domain will be here from minus infinity to infinity. We can input any value of x into this function. Yeah. So if we put x is equal to 0, then you will have here a 2 raised to 0. So 2 raised to 0 is 1. It means that for x is equal to 1, you will get y value has 1. For x is equal to 0, you will get y value has 1. So your point will be here. And let's see for x is equal to 2. For x is equal to 2, you will get 2 raised to square. So this will be 4. Means y value you will get as 4. So this will be here. Let's consider for 2 raised to minus 1. You can put x values as, and your domain is from minus infinity to infinity. Means you can also include this negative values of x. If your is 2 raised to minus 1, so it will be like 1 and this 2 will come in denominator means half. So y value is half at this point at x is equal to minus 1. For example, your minus 1 is here. So you are getting half at this point. So you can have this view of this curve as like this. So it will be going like this. And it will tend, y value will tend to 0 positive. What this means? 0 positive means a little bit value that is greater than the 0. For example, 0.00001. So this value is a little bit greater than the 0. So your exponential function when this will go to the minus infinity, so this will tend to 0 positive, and when it will go to infinity, so your y value will go to also infinity. I am saying is that when your x will tend to infinity, means when you are having this x at infinity, so your y value means your function value will also go towards the infinity, means this function of x value will also tend to infinity. So we had seen for a greater than 1. Let's see for a between this 1 and 0. Means you are having base that is greater than 0 and it is lesser than 1. So let's consider base has half and this x values will change. So let's consider half raised to minus 1. So this will be like this denominator will come up with the power 1 and you will get this as 2, and what will come as half raised to minus 2. So this will be like this denominator will come up with the positive power 2. So you will having this 4. And what will be half raised to minus 3? So half raised to minus 3 will be this 2 will come up and this 3 will be a positive power for this, and you will 2 cube is 8. So you will get this value. And what will be 2 raised to 0? 2 raised to, sorry, half raised to 0 is equal to, half raised to 0 will be, half raised to 0 is nothing but is equal to 1. Half raised to 0 is equal to 1. And what is the half raised to? Half raised to 1 is half, and half raised to 2 is 1 by 4. So let's draw graph for this. So this is your origin, and when your x is equal to 0, you are getting y value as 1, and when your x is equal to minus 1, that is here, you are getting y value as 2, so it could be here. Then if your x is equal to minus 2 here, then you are getting y has 4, so it will be here. And when your x is equal to 1, you are getting half, means here. And when your x is equal to 2, you are getting y value has 1 by 4, so it could be here. This is your 2 coordinate of x, and this is your 1. So you can see that you are having graph like this. But in the this is a reflection of the graph that we saw previous. So this is the reflection of that previous graph was like this. This was also passing through this y coordinate 1, but it was the reflection of this curve. So we have seen this when a will be greater than 1, when your base will be greater than 1, and when your base will be between the 0 and 1. So we can conclude that your range of this function is always positive value, since this is your exponential function. So your range is from 0 to infinity. Means only positive values are coming with the help of this function. So let's see logarithmic function. So logarithmic function is like this: function of x is equal to log to the base a of x. So this is a logarithmic function. So we will put x values. This will be our input. And so what will be our domain, means possible input. The domain could be from is from 0 to infinity. So we have to put positive values here, and we can't put 0 here. Means your x should be greater than 0, and this your base should be not equal to 0, and this should be greater than 1. This logarithmic function can be written in the exponential form as this is your log to base a. So in exponential we can have this base a, and log of x means this will be answer when we raise this base to some power. For example, that power be small p. So a raised to p is equal to x. This is in the exponential form. If we have to write it in the logarithmic form, so it will be like this, and this log answer will come as, that is log a to the base a of x will be equal to p, because this have power, this base a have power p. Okay. So now we know that our domain will be from 0 to infinity. So what will be the range of this log values? So log of, because of the log, we get range from minus infinity to infinity. Means we also get negative values, and we also get positive values. So this is your domain that comes only positive values. That will be only positive values, and we will not include 0. Your x will be greater than 0. Let's see some examples of log. For example, you have this log 2 base 2 of 4. So this will be 2 because your base is 2, and this answer is your power. So 2 raised to 2 is equal to 4. So this is in the exponential form, and this is your logarithmic form. So let's see where this logarithmic function is used. So this is basically used for when your data values are very far away from each other. For example, one data value is 10,000 and one is 1000. So if you draw this data values on a graph, so for this the graph becomes diminished, means you can't see the bar graph. So making these two data values comparable, they convert it into the logarithmic form, and they do it so using the base 10. So 10 raised to 4 will be this 10,000, and this 1000 will be 10 raised to 3. So by while comparing the use like this, log to the base 10 of 10,000 is equal to 4, and for this they can be written as log to the base 10 of 1000 is equal to 3. So now this data values becomes log values become as 4, and this became as 3. So this 3 and 4, that is the log values of the data values, are now more comparable. Okay. So let's see your logarithmic function graph. So I'm drawing the curve. So we were having this logarithmic function has log to the base a of x is equal to, let put it as y. So this will be your y coordinate and this is your x coordinate. So when your base will be greater than 1, then your logarithmic functions graph will be like this. And this will be your x coordinate has 1 and this will be your origin. It means that your when your x value will be 1 to the base a, so your y coordinate will be 0 when your this base a is greater than 1. So this is your graph when your base is a is greater than 1, and let's see when your base a is between 0 and 1, then your graph will be something like this. Your graph will be like this. This is when your a this base will be between this 0 and 1.